Alright, here's a quick overview of my game. My wife made me this sexy little box with the pretty stars. Um, it's not even done, I'm missing a button. And I haven't plugged it in, so you can't see it. But basically, there's 10 rounds, and the lights go around, and these are lit up, these red lights. As soon as a light is within the range of these lights, you hit your button. And if you do that, you get a point. And each round the lights go around 5 times, so you have the possibility of filling up all 5 of these points. At the end of the round, your points tally over here, and of course you do that 10 times. Each round the lights get faster and faster, it gets harder and harder. So each round you may lose points, but they always tally here, and at the end whoever wins. Originally I had an LCD screen, but I want to keep it more basic, so I'm probably going to put another light, like a blue light, I will put on here. Whoever wins, their light lights up. So it's really basic. Here's the counter. Each digit is controlled by 2 chips. So this is a 7-segment decoder chip. So basically you feed it in like all zeros, and it automatically it's connected to, this is basically 7 lights. 1, 2, 3, 4, 5, 6, 7. So you feed it all zeros, and it knows what a zero is. It'll light up this light, this light, this light, this light, this light, this light, this light. So it'll light up all the lights. You feed it a 1, it'll light up this light and this light. Now, I don't want to use 4 wires to control each digit. That'd be 8 wires. So I hook it to a decade counter. A decade counter feeds those 4 bits in, and it's just one switch. You switch it up and down, and it counts 1, 2, 3, 4. The reason why it's called a decade counter is it only counts up to 9. Once it goes to 9, it goes to 0 and sends the carry bit over here. So it'll go 9, 0, it'll carry the 1 over here. So it'll say 9, it'll send a 0 over here, it'll send a 1 over here, which will then light up this 1. So, given all these chips, and of course you have capacitors here to limit the range, because I'm doing 5 volts. So just with these chips here, and this is a inverted Schmidt trigger to smooth out the button as you press it. So just this, you have 2 lines. One line, if you flip it up, down, it'll count 1, 2, 3, 4. It'll go all the way to 99, and then go to 0, 0. And then there's another control line to reset it. So we'll take that out. Hold on. There, you can get an idea what that looks like. Let me focus here. There we go. My beautiful soldering. I've gotten really good. You can see the solder's really close, but it's not touching each other. Looks like a jangoed mess. The other side I didn't even finish yet, because once I did it once, I was like, I don't want to do it again. That's boring. I was going to do it last, but I haven't got that far. Now this light, this looks all pretty, but it's a trick, because I didn't want to show chips. I didn't want to show capacitors. I just wanted to keep the lights. So, hold on. Get this bad boy out. Okay. There we go. This is like a storybook. So here you got all the lights. They're set up as an array. So you can see 16 lights are all soldered together, the ground. The voltages are all hooked together. There are 5 banks of 16. Those all go over to this board, which is hidden. This board has all the chips that's controlling it. These lights were just for fun, testing it. So the board is controlled by 2 4 to 16 decoders. They're active low. So I needed to put 3 inverter chips to make it so they light up and not everything's lit up and it's a blank light, And then there's 2 shift registers here. These are the shift registers that control the lights in the middle, the points, these ones over here. So all I'm doing is shifting a 1. So shift a 1, shift a 1, shift a 1, and of course 1 is power, so it lights up the light. So that's that. And then this is a shifter because you have to select the numbers here, which ones are active and which ones aren't active. So you can see, and it looks crazy, but it's kind of nice. It just sort of folds in like a magic book, There we go. So it's a nice and clean collection. So the one thing about doing hardware, software, you can look at code and you have no idea how long someone did that. I mean, depending on what language you're using, it can be really short. But the cool thing about hardware is there's no denying I put in a lot of freaking effort. And I did turn it on first for the whole class so they could all see what's going on. So there's a quick over. Now, of course, this is all being controlled by an Arduino. So the Arduino is running it, so I can program. Now, I want to do it where there's no Arduino, no high-level language. I want this whole thing to be controlled by simple logic gates. But, you know, I have to do that in my spare time, just for fun. So apparently I'm a bigger nerd than I thought. I don't know. But I'll post a video in a week or two where it'll be working. Of course, it'll be working using the Arduino over here. You can get on Amazon for 20 bucks and take it from there. Oh, and there's also a speaker. But the speaker I need to solder. And of course, it makes a cool noise and stuff. So there's your preview. All right, bye.